Okay, now let's familiar with a few terminologies associated with the diffusion. The terms associated with the diffusion process. Okay, so starting with Kirkintal effect. So we already discussed about the binary diffusion couple to demonstrate the phenomenon of diffusion. I hope you are remembering. So there, in a binary diffusion couple of metals A and B, the rate at which A and B diffuse each other. So we discussed the example of copper and nickel. I hope you remember the copper migrated to nickel, nickel migrated to copper. The rate at which A and B diffuses in each other are not equal. Usually, the low melting point component diffuses more faster into the other than the other way. So that effect is called the Kirkendall effect. The low melting point migrates faster. The second term is diffusion flux. It is nothing but I already told you the diffusion is nothing but the material transport by atomic motion, or it's nothing but the mass flow rate, isn't it? The mass flow by which the atoms change their position relative to the neighbors. So the diffusion flux means it is represented using the capital symbol J, capital letter J. It's nothing but the mass flow per unit area per unit time. Okay, not atom. The mass flow per unit area per unit time is known as the diffusion flux. Or it is nothing but the number of atoms of one plane moving to unit area of another plane per unit time. That is also correct. The number of atoms, that is the mass flow of atoms per unit area per unit time. Number of atoms of one plane moving to unit area of another plane per unit time. And you may please note that the diffusion flux is always proportional to the concentration gradient. Now, what is concentration gradient? Now we know the what you mean by concentration, isn't it? There will be, if you remember back the diffusion couple copper nickel case we discussed, the concentration of the diffusing element. So if you plot the concentration of the diffusing element versus the position, the position within a solid, and the resulting curve is called the concentration profile, and the slope of that curve is called the concentration gradient. The curve will be such that on the y-axis the concentration of the diffusing species is taken, on the x-axis the position, the position along the solid bar is taken, and the curve is called the concentration profile, and the slope of the curve is called the concentration gradient. That is nothing but dc by dx. Okay, and another important term we use is a steady state and non-steady state diffusion. This is very important, based on which we are going to discuss later the two laws of diffusion: fixed first law and fixed second law. That is based on the steady state and non-steady state diffusion. Okay, so here I write J depends on time and not time. J is diffusion flux, which means in the case of steady state diffusion, the diffusion flux does not change with time. In the case of steady state diffusion. So I think in the opposite way I wrote it here. In the case of steady state diffusion, the diffusion flux does not change with time, or the flux at any cross-sectional plane along the diffusion distance remains constant. If you take any cross section along the diffusion distance or along the solid, the flux remains the same. Whereas in the case of non-steady state diffusion, at any given instant, flux at different cross sectional planes along diffusion direction are different, or they are not equal. That is the case of a non-steady state diffusion. The diffusion flux changes with the time, or in other words, if you take different cross sectional planes along the diffusion direction in a solid, that flux will be different. So the flux at a given cross section is a function of time, that is non-steady state. Okay, and the another important point is activation energy. So activation energy means when the atoms diffused from one metal bar to another metal bar, while diffusing, the atoms will have to overcome the resistance and barriers to their movement, and for that some energy is required for this. The energy required by an atom to overcome this barrier is known as the activation energy of the diffusion. So this activation energy of diffusion depends on various factors like type of diffusion, crystal structure, type of bonding, size of atoms, etc. And another important point which I have not, yeah, I missed it here. So diffusion coefficient or diffusivity. So in between we need to discuss this point. I skipped it. Okay, the diffusion coefficient or diffusivity means it's an index of the rate of intensity. It's an index of the rate or intensity at which the atoms diffuse. The atoms, when an atom from one metal bar to another metal bar get migrated, and what is the rate or what is the intensity at which the atoms diffuse? The diffusion coefficient or the diffusivity is an index of the rate or intensity at which the atoms diffuse, or we can simply say it's an index to represent the rate of diffusion, and it depends upon the diffusing species, whether which species is diffusing, copper atom or nickel atom, the composition of the medium into which diffusion takes place, and the temperature. These three things the diffusivity or the diffusion coefficient depends upon. Okay, thank you.